Okay, today we're doing 4-5 notes. So go ahead and put 4.5 up top. It is dilation notes. A dilation is a transformation in which a figure is enlarged or reduced. In other words, it's made larger or we're making it smaller with respect to a fixed point called the center of dilation. And a scale factor called K. We're calling the scale factor K. A dilation is similar to the original figure, which means the shapes will have the same angle measures. Our side lengths will be shorter or longer. So you can put side lengths shorter or longer. It's going to depend whether you're making it larger or smaller. Dilations are centered around the origin unless otherwise stated. So they'll be centered around 0, 0. Okay, on your scale factor, you have a couple of different ways that you can do this. We can use your image length, which is your second one we get, over your pre-image. Your pre-image is the first thing. Your image is the one you transfer it to or that you're making. So you can think of your pre-image if you're working on a real-world picture, or you can think of it as the actual length of whatever you're using. You can use this, or you can do your new one, which will be the one you're creating, over the old one, which is the one that you had. And these are going to be as fractions. You're doing them as fractions. You got to make sure that you do reduce these down. Reduce your fractions down. If the scale factor is greater than 1, and we said scale factor is going to be the letter K, so we can put if your scale factor, if K is greater than 1, the figure becomes larger. And we call that an enlargement. If the scale factor is between 0 and 1, and we're going to put our scale factor for K, and it's between 0 and 1, and those would be fractions, it becomes smaller. And we call that a reduction. Okay, the way we're going to write our rule is x multiplied by k and y multiplied by k. Sorry, that was the bell. Where k is represented by the scale factor. Now, normally when we multiply something times x, we don't write it after the x if it was a number. So I'm going to put k x, because whatever number you have for your scale factor, you're going to multiply it times your x. You're also going to multiply that number times your y to get your new coordinates. That is going to be your rule. So here's an example. If the scale factor is 3, how would we write the rule? My scale factor, so k equals 3. So scale factor is 3, so 3 times our x and 3 times our y for our rule on that one. Okay, let's do another example. Triangle ABC has the vertices right there. What are the vertices of its image with a scale factor of 4? So we know our scale factor, I'm going to put k equals 4. We know our rule for this would be 4x and then 4y. So if I have my A, B, C, these are my old ones, 0, 2, 4, 4, and -1, 4. To change it, for one thing, since it's a whole number, it's going to be getting larger. It's a whole number, so it's going to be getting larger. So it would be an enlargement, so that I know my Numbers over here should be larger. For my A prime, it would be multiplying the 0 times 4 would give us 0. 2 times 4 is going to give us 8. For B prime, 4 times 4 is 16, and 16. So C prime, we would have a negative 1 times 4 would be a negative 4, and 4 times 4 is 16. So that would be my coordinates for my dilation. Okay, let's go and look at our next example. Tells us triangle, pull that down. PQR has those vertices. It's dilated by a scale factor of 1/2. First, we know if it's dilated by a fraction, by a scale factor that is a fraction, that it's going to be a reduction. It's going to make our image smaller. So we know it's going to be getting smaller since that is a fraction. Okay, we know that our K, which is our scale factor, is 1/2. So our rule is going to be 1/2 times our X and 1/2 times our Y. That is the rule. So I have P, Q, and R points that we can go and write down to see what our P prime was going to be. P prime, if we multiply a negative 2 times 1/2, that's going to give me a negative 1, and 4 times 1/2 is going to give us 2. So for our Q, 4 and 4 is our points. Q prime, multiply the 4 times the 1/2, and we're going to get 2 on those, and our R is for negative 2. So when we change that for our R prime, we're going to have 2 and negative 1 when we multiply it times the 1/2. Then they ask us here, we're going to graph our pre-image, our first coordinate. We're graphing the pre-image. So if we go and graph the pre-image over here on what they gave us, we would need a negative 2, 4, and that is the P, and we need 4, 4, Q, and for our R, it is 4, negative 2, and that's our R. So when we go and connect these, this is our pre-image. This is the one we started out with. Okay, and now we need to go and graph our image to see what it would be. And I'm grabbing another color. Okay, if we go and graph our image now, our P prime is a negative 1, 2. Our Q prime is 2, 2, and the R prime would be 2, negative 1. Okay, here's what our shape would be with a scale factor of 1/2. This is our image. It's our second one. So you can see we reduced our first shape by 1/2. Okay, let's go to a real world example. Okay, if you are making your own photo stickers, your photo is 4 inches by 4 inches, so it is a square. The image on the sticker is 1.1 inches by 1.1. What is the scale factor of this dilation? So if we go back and look at our rule, it tells us right here we can use the image length, which is the one we're creating, over our pre-image, which is the actual length, or we can think of it as new over old, it doesn't matter. So if we did our image, which is going to be what we're going to end up making, image over our pre-image, or you can think of it as new over old. Either way, we would have our, over here on our image, the one that we're going to create, we would have 1.1 over 4, because that is what our actual one is, or our pre-image, and that doesn't reduce down, so our fraction and our scale factor on this one would be that. If it reduced down, we would have to reduce it down, but that is our scale factor. But make sure you put on there, you must reduce the fractions if they're able to. That's it on 4.5.